Yes, we are looking at the mechanism of the second one because we have looked at the mechanism of the first one. So let us see outright the mechanism of the second one. Begin in the same way, start by breaking the chlorine bond, then after form an electrophile. So that electrophile is the one which is attacked using the benzene ring. Let us see that mechanism. Chlorine, you bring iron. That's what we have. So we are supposed to break the chlorine bond so that the iron takes away the halogen. That's why we are calling it a halogen carrier. So this is what we have. Now, as we have this one, we have the chlorine positive recharged, then plus iron. Now this one is now negative recharge because it's carrying a halogen. So from there, we have this one here, bring benzene. A benzene has pi electrons. So the chlorine, which is positively charged, is attacked. We talked about electrophilic substitution reaction, and this is what we have. So one of the carbon atoms of benzene receive the halogen, which is chlorine, and then the other one becomes positively charged. But the one that has received the halogen has a hydrogen, which is lost in form of a proton, and when it is being lost, it is accepted by the halogen, which has been carried by iron. So this one has to pick up that proton, and the electrons in the bond come back to stabilize the benzene ring. Then after we have this what we have, then plus hydrogen chloride, hydrochloric acid, then plus iron 3 chloride. So iron 3 chloride also being formed is already our, so it is not part of the products. How it's work, it facilitates the reaction. So this is what we are trying to have, and that is what we are calling halogenation of benzene. Of course, we have reacted with bromine, and we have reacted with the chlorine. The reaction is of benzene with bromine and chlorine, little bit expert, some are faster, and reactions are possible a little bit. When it comes to reaction with the fluorine, the reaction is a little bit explosive and takes place, and sometimes we don't use it because it takes place but is uncontrollably. You cannot easily control it. Then in the same way, when it comes to reaction with the iodine, since it is a solid at room temperature, the reaction is a little bit hard, but of course we have to apply some other conditions for the reaction to take place. So at this particular moment, we want to end here for today. Today we have looked at halogenation of benzene. Then when we appear again, we shall also look at another reaction which involves the benzene range, and that is acceleration when we will come back in the next video. See you.